Well, good evening. All right. Welcome to the December edition of the meeting of the Ottawa Centre of the Royal Astronomical Society. I'm Bill Wagstaff. I'll be your host tonight. Welcome all the members. And do we have any new people tonight? Anyone who's not attended a meeting before? Holy moly.
Brian McCullough, right.
Yeah, I never know how many of you to believe. Anyway, welcome. welcome. The meetings are open to the public. They're not specifically a member-only affair. So we welcome everyone to come along and enjoy the meetings, enjoy the content that's being provided. Tonight, it may drag a little bit. AGM tonight, so we're going to start off with about 40 minutes or so of the centre business. We need to get that out of the way for the year. And then we've got a couple of our regular presentations to bring up after that. A little bit of a thin program tonight because of the AGM content, but I'll be doing the Ottawa Skies, talking about what's coming up over the next month. Eric Kuyala will be talking about an expedition up to Elsevier Lake, and then we'll have our observations as usual tonight. All right, so with the business out of the way, I guess we get back to the business of observing and talking about the sky. So I've recently kind of taken over doing the Ottawa Skies segment. I'm finding I'm enjoying it more and more. It gives me an opportunity to look into what's going on in the coming month and browse around the web, find a few images. It's pretty fun. I don't know if I want to give it up, but I'd have to say, if there is anyone else who is interested in contributing and doing this as well, by all means, come mention it to me, and I'd be happy to coach you. Otherwise, I'm happy enough to keep doing this as well, as long as you figure I'm doing it well enough.
Do we have to be able to identify that constellation on the screen?
We'll make an exception in your case, Brian. All right. So anyway, just to get underway, quick browse of what's going on over the next month. Next, please. First of all, solar. We have a nice big new sunspot has just come over the northeastern limb in the last couple of days. It's looking pretty good. It's it's been pretty close to the limb so far, so it's not really completely apparent how big it's going to be, but it looks like a pretty good one. I've got an image that a fella in Belfast, Northern Ireland, shot of it yesterday, and you can see already it's looking like a fairly impressive one. So if you have an opportunity, if you've got a solar filter or access to something like that that's going to save you from burning your eyeballs out of your head, I'd suggest taking a look. It should be a fairly interesting one to see. I myself, just for interest's sake, I've got a set of solar filters I made up for my binoculars. So I've got a set of 10 by 50 binoculars and got a bit of solar film from our local supplier, Focus Scientific, and a little bit of cardboard tube. And next thing you know, I've got a pair of pop-on solar filters. Work pretty well. You can spot a lot of this. So if you're thinking that might be a good thing to do, check with them. It's pretty cheap to do. Just be careful. All right, next up, please. For Lunar, so we've got new moon is in 2 days. It's going to be on Sunday. Not sure how the skies are going to be. This is not the greatest time of year for observing in Ottawa, as you're undoubtedly aware. I was looking in the Observer's Handbook just the other day to see what the probability was, and apparently there's about an 80% average probability of being clouded over this time of year. So, It's pretty hit or miss, but if we keep in mind all of the things that are coming up, who knows? We might get a gap in the sky at one point or another. So new moon, opportunity to do a bit of observing with a fairly dark sky. We've got a total lunar eclipse coming up the early morning of December 21st. So there was a little bit of confusion earlier on in the announcements. Make sure that you know it's just after midnight, the early morning of the 21st, not the night of the 21st, okay? So it's, yes?
Sorry, actually, the second contact, when it starts to get dark,
Mm-hmm.
is at 1:33
Thank you.
and ends at 5:01.
Yeah, sounds good. I knew I could rely on you, Gary. Anyway, it should be interesting. You know, if we've got a sky, if we've got some opening to look at, they're always great to look at. I love the copper color that you get. And you never know how coppery, how red it's going to be. They're all different. Anyway, it's a good one for us. It's visible from Western Europe, all of the Americas pretty much, Pacific Ocean, New Zealand, northeastern Australia, northeastern Asia, you know, so it's pretty much, we're right in the middle. Well, I think the middle is like Hawaii, something like that, but we're in good position to see the entire eclipse. It'll start, as Gary says, about, call it 1:30 in the morning, something like that, and carry on. So it's a little bit late.
That's when it begins to get dark, but the totality,
Yep.
it's around 3:10 for this every 2 minutes.
Yeah, you bet. Okay, so it'll be a bit late, but I think it's worthwhile. You know, if the sky looks good, see if you can see it, right? It's always a treat. I haven't seen one in a couple of years now. Next up. It's a total eclipse. It's going to, be completely in Earth's umbra. It's not central, as you can see here, kind of a plan of it. As Gary says, he's bang on as far as the start and end times, that sort of thing. So good memory there. Anyway, this is roughly what you should be seeing. Next, please. And here's basically the positioning. Do you have the laser? Oh, here it is. Okay, I think it's this way. Yeah, that's the laser. So as I say, this is kind of the middle. It's not quite Hawaii, but it's off the California coast. Is kind of the middle of it. But we're well in here. The dark area here is the part of the world that's going to be able to see the entire eclipse from beginning to end. It'll be up in the sky. Further east here in this area, it'll already be eclipsed. It'll be eclipsed when the moon sets, so they won't be able to see the end of the eclipse because it'll set for them. The gray areas, they're not going to be able to see it at all, and of course over the other side here, Japan, for example, the Japanese will see the moon rise while eclipsed, and they'll be able to see the end of it. Okay, so we're really well placed here, fairly early in the evening, to be able to see the whole thing. It should be decently dark by then anyway. Okay, next please. Next up, so planetary observing. There's a number of planets that can be observed this month. Mercury is pretty low in the evening sky, but nevertheless, it is available right now, and towards the end of the month, it'll start appearing in the eastern sky at sunrise. Neptune is setting quite early, but is observable. It's pretty low, though. Jupiter is very well placed right now in the early evening, so that's kind of the hot one to take a look at right now. Uranus is also well up, and it's not too far away from Jupiter, so if you haven't observed it yet, I'd suggest taking a look. Saturn is well placed before dawn, but it's pretty late. A lot of us don't want to stay up all night or get up really early in the morning, so you may or may not want to observe. And Venus, of course, is our morning star during this month. So should be very nice. It's very, very bright. Bit of a crescent right now. Next, please. Mercury in particular, western evening sky. Greatest elongation was a couple of days ago. Elongation, for those that aren't familiar with the term, basically apparent distance from the sun is, kind of the layman's way of looking at it. So, best positioning for observing was on the 1st, but it's still going to be good for a few more days. If you get a clear sky, you'll want to catch it. If you're up somewhere like Champlain Lookout or somewhere high where you've got a good horizon, you should be able to observe it over the next little while if you get a sky. And then, as I say, reappears in the morning sky late in the month. Next, please. Jupiter, well placed. The southern equatorial band is starting to return. So you might remember over the last couple of months we've been talking about the southern equatorial band on Jupiter. One of the dark bands had completely disappeared, which is kind of unprecedented. We haven't seen that in a long time. It's been missing for, must be almost a year now, and we're seeing signs that it's starting to return again. Next, please. So challenge, can you observe? Right now there's kind of a ripply disturbance. I'm sure some of our more avid planetary observers have seen it already. It's not too hard to see, but if you get an opportunity to take a look at Jupiter during the month, take a look and see if you can identify it, see the disturbance. Next, please. So here's an image shot not too terribly long ago, and this is what I'm talking about. You can see there's kind of a ripply looking disturbance here. This is not actually the band itself, but it's believed to be the beginnings of some turbulence, some high-level storms that are eventually going to clear away what's believed to be cloud cover over the darker bands, and it's believed that over the next while we'll see them start to appear again. So it's kind of an opportunity to see, a huge evolution. This is a gigantic planet. The feature we're looking at right here is very, very large. And to be able to observe it from a backyard telescope, that sort of thing, is a rare opportunity, I'd say. Next, please. Okay, meteors. We've got a shower. The Geminids is coming up. December 13th is the peak. So that's the night of the 13th on to the 14th, just so we're clear about that. If it's clear, by all means, jump out and see them. They should be pretty good this year. I don't know if Pierre Martin is here this time. Is Pierre here? No? Okay. Pierre is our avid meteor observer, of course. I was sure that if he was here, he'd have something or other to say about it. But since he's not here, just have to go out and see them themselves. Yes, Gary?
About 120 per hour,
About 120?
and that's pretty well a decent number for the Geminids every year. It's pretty well constant. But they're very slow compared to the Perseids, which are about 72 kilometers per second. It's about 35 kilometers per second. Very graceful.
Oh, very nice.
But if you can get out, it's really worth going out and catching them.
Yeah, I'm hoping for clear skies myself. We'll see. Okay, next, please. So just the positioning, so you're kind of familiar. Gemini here, and you can see they're kind of inverted here. There's their heads, Pollux and Castor over here. What is it? Basically, the radiant is just off beside Castor's head there. So
That illustration looks like it was generated for maybe down in the southern hemisphere. It's not really wrong.
yeah, it might be. I just picked it up this afternoon. I was in a hurry to try and get an image. I probably picked it up from the wrong. Yeah, because it's inverted, right? Yeah, you're right. It didn't occur to me to think about. yeah. It inverts where the ground is too. That's an interesting effect. That I haven't seen a star diagonal quite like that before. But anyway, still gives you an idea. The position of the radiant is the same. Just imagine you're standing on your head. Your ground's up here instead. Anyway. Gives you an idea. So that's where they should be coming from. Of course, as usual, when you're doing meteor observing, don't look straight at the radiant. You won't see very much there. Look off to the side. Try and cover a lot of sky, and you'll see. They seem to come from that point, but you're going to see a lot more over here than if you look directly at the radiant itself. Next, please. And it's going to be dark out. Okay, so I think we're a little bit early for the break, but I think that's kind of the way we set things up tonight. We actually expected the AGM to run a little bit longer, so rather than trying to fiddle quickly, we'll take the break early. The observer's calendar is available, I believe. Mike, have you got them out there?
Yes, I do.
Good. Okay, so Mike's got a table outside. He's going to be selling the Observer's calendars. Really good deal, $15 for one or $25 for two. Much less than you'll see them for on the RESC national website. So it's a really good deal for members. They're going fast, so I would pick them up while you can. In fact, I think I'm supposed to pick one up for somebody tonight, if you guys don't beat me to it. So let's go ahead with the next part. We've got a talk here from Eric Kuyala, who's going to talk about an expedition over to the hinterlands. Come on up, Eric.
Good. Okay. Hi, everyone. You may recall a couple of months ago, I did a presentation. Chuck O'Dale, your ex-past president, and I flew over Algonquin Park and did a tour, and we flew over the Brent crater and then flew to another site which we thought could be a crater. That was in August. So we flew up to the Brent crater, and then we made our way down to this place here called Elsevier. And after that, we did a day trip on the ground to the area just to scout it, to find out where everything is. And that was in September. And then in October, we finally did our trip to Elsevier to find out if this place, in fact, is an impact crater. Algonquin Park, some of you may not know, is about 2 hours drive from Ottawa. Ottawa would be about here. And then we went down the Highway 60 and then accessed the southern end of the park by road into here. And if we can go to the next slide, please. And found our way to this site here, which is Lake Elsevier on this side. And this is called Lake Roundbush. This whole thing here we thought could be an impact crater. And it looks very similar to Brent, because Brent has two lakes like this with a joining spot. And sometimes when I was going through the photos, I would actually confuse the two. They look so much alike. So this was from our aerial exploration. Next slide, please. And our objective to find out if Elsevier was in fact an impact crater was this outcropping here. And so our ground expedition to the crater on the weekend of October 23rd, we got to the park, and if we could go to the next slide, please. We got to the park and to the southern boundary about here, and then made our, let's see if I can see that right. It's a little funny from this side. Made our way up this cart trail, and then to the Allen River, and then to the lake. This is Lake Elsevier here. Next slide, please. To get to the crater, we had to haul the canoe 4 kilometers down the trail. And I'll tell you, Chuck O'Dale deserves a medal for pulling this canoe with a harness down that cart trail. Thank you very much, Chuck. He had trekking poles, and we made it down to the river. Next slide, please. This is the Allen River that leads there. So we got to about here, this is the cart trail, and then we have to go up this river here. So it's a small river. It's not a big river. I've done much bigger rivers. But we went down this river, and we got to a point on the river where there's a portage that leads to the lake. If we could go to the next one, please. So here we have the river, and we went down to, let's see here, to about here, and then portaged to here, and then to the lake. This is Elsevier Lake here. So this would be the crater here. And so we went down. We actually camped on the river the Friday night because we didn't have enough time to actually get to the lake. Also, we decided not to camp on the lake because we had a lot of gear to haul, you could see from that previous shot. So we camped on the river, and the next morning we decided to do our trip to the lake. If we could go to the next slide, please. This is what the river looks like. It's full of beaver dams all the way up. I didn't see a single beaver, but we saw all these dams. We counted at least 8 dams, right, Chuck? about that. So there's Chuck standing on one of the dams, and we're actually paddling up the river because the water flows down this way south. So we're paddling up towards the lake. If we could go to the next slide, please. And just before we got to our campsite, we saw Mr. Moose here enjoying the view and that, and apparently he was bothering Chuck all night that night, Friday night. Hey, Chuck, he came to visit you at the campsite. Yeah.
That's not a Sasquatch?
No. Algonquin Park is full of moose, and I wasn't surprised to see one. But yeah, you don't want to bug them too much. Next slide, please. So next morning we get up, and what do we find? So this is the river, and we camped right on the shore, and Chuck made coffee, and I got up and I saw him drinking his coffee there, happy as anything, and that's how our Saturday morning started. And okay, next slide, please. There I am, big smile. Next slide, please. And this is the little lake in between Alcivar Lake and where we were camped on the river. Next slide, please. And this is the portage sign for getting to the lake. Next slide, please. And we had to haul. Fortunately, we didn't have to carry everything with us, just the canoe and our day packs. And I'm used to portaging. I've been doing it all my life. It was a little trickier for Chuck, you know, especially after hauling that canoe all that way down that trail there. Next slide, please. And here we are at Alcivar Lake, finally. And it was something we'd been waiting for a while to do. Next slide, please. Now we're on the lake, and this is the outcropping I showed you before. This was the main target of our trip, to find out if we could find impact melt, shatter cones, breccia, any tangible sign that an impact had happened here. Next slide, please. I love this picture. I think this is one of my favorite pictures of it. You know, it's a perfect reflection. Saturday, I don't know if anyone remembers that Saturday, October 24th. It was a calm, warm day. It didn't feel like October at all, and we loved it. Next slide, please. Once we got to the outcropping, we started to examine the rocks, and Chuck has more knowledge on what to look for than I do. So I was learning a lot from him, actually, about what was there, including a new word I learned called pegmatite, which is a type of rock that we found there. Next slide, please. And the outcropping, is very interesting geologically, but it didn't tell us very much about whether there had been an impact there. In fact, it sort of leaned the other way, which was a bit disappointing that we couldn't see what we wanted to see. We would have preferred seeing a big mound of impact melt, like we had seen on craters that we knew were craters. Next slide, please. And we did find some markings on rocks which we thought were interesting that had some striations on them, but still not shatter cones. Next slide, please. One thing I did, which I hadn't done on previous trips, and I regretted that, was taking water samples and testing the pH level. Because on Brent Crater, it was noted that the water is more alkaline than lakes normally are. So I did a pH level test in here, and they were consistent with normal lake acidity levels. They were not alkaline. They were actually below. They were about 6.8 or 6.5 pH level. They would normally be above 7 if they were alkaline. Next slide, please. And this is the spot in between the two lakes. Roundbush Lake would be back here. So we went up to this spot. You see Chuck's hand there holding the canoe in place while I stand up and take this picture. We decided not to go to Roundbush Lake because it would have been a lot of work to get through all of this. So we continued staying on the Alcivar side of the lake. Next slide, please. We found an island with a funny-looking bird's nest on it. I don't know what kind of bird would build that, but we decided to take a break. A hawk's nest? Okay. An osprey's nest, of course. Okay. and took a break on the, you know what, I thought it was an osprey's nest. I've seen one before, I just wasn't sure. Thank you. Next slide, please. There's Chuck, relaxing after I kept tiring him out doing all that canoeing and paddling and pulling the canoe and that. And the trip was actually was relaxing. You know, we were able to take our time and enjoy ourselves. It's, you know, when we explore, there's the serious side where you want to do some science and learn things, but you also have to enjoy yourself. And that's what we did on this trip. Next slide, please. There's a better shot of the nest. Next, please.
Except for humans.
Yeah, you probably could sit in it. Yeah, that would make a funny picture. Found some quartz rocks on the island. No particular evidence that there was an impact there, but it's nice to take those kinds of pictures, to show that you are looking for things. Next slide, please. And there I am relaxing, a little scenic picture with my canoe. That canoe, by the way, has been all over the place. It's been on Lake Superior, it's been on Manicouagan, it's been on Lake Mistassini, it's been in many trips in James Bay, going down rivers, and I've had it for almost 20 years. It's an Old Town tripper, and it is a workhorse. You cannot go wrong with this canoe. It's a tank. You can bash through rocks with it, everything. It'll carry a ton of stuff in it without any problem. And because it doesn't have a keel, it's very easy to maneuver, especially in rough water. When you go into places, especially the reservoirs tend to be very dangerous, and you're better off having one of those. It's built for whitewater canoeing, actually. Next slide, please. Okay, I think our slides may be out of sequence here. Anyways, this is a picture of Chuck on our way back, and if you look carefully, you'll see something on his nose. That's when his nose met the side of my canoe on the way back. And we decided to take the river back almost all the way back to the car. The river actually is not far from the car, but we took the cart trail up because we thought it would be easier. On the way back, we took the river back, which was a big mistake because the river has trees fallen across it all the way down. If we can go to the next slide. And it looks like that. So we had to pull the canoe over all these trees, and I said to Chuck, we must really love craters, don't we? We really love craters. And he said, yes, Eric, we do. And so we struggled our way back to the car that Sunday afternoon doing that. And next slide, please. And that some places it narrowed like that, and it just got better and better as we got along. Now can we go back to the first slide? What I want to tell you now, yeah, the aerial photo, yeah. What I want to tell you now is that we did not find any evidence that it's an impact crater. So for now, it remains a mystery as to whether it is or not. The only sure way we could find if it's an impact crater is with about $1 million to take a drill and to drill down through the rock to see the layers, what they're like, and to find evidence of impact melt that way. So if you have $1 million, give me a call. And so I've come up with 3 possibilities for this site. And next summer I plan to actually go back there. See, the river is down here, okay? So I plan to come back, and that cart trail actually leads all the way to the top of this ridge here. You can actually walk it in a day and back. Chuck wanted to go up to here, with the canoe, and then have us slide down to the lake. And I said, no, let's just take the river. But you can do a day walk to the top here, and I want to explore the top to see if I can find any evidence there. Anyone who wants to join me for a nice day trip, let me know. But I've come up with 3 possibilities in regards to this place. One is it is not an impact crater. 2, it is an impact crater, but we just haven't found signs of it yet. And 3, it's an impact crater, but all the signs have been washed away. Now, this site, compared to Brent, it doesn't have the ridge that Brent has. Like when we went to the Brent crater, we actually had to go down into the lakes. There's no sign of that here. The Alien River actually comes from here, from the north, and then makes its way down, and then goes down this way, heads south. Well, that means if it's heading down and it's pretty well level, that means any ridges have disappeared in here that would have prevented that. So I'm thinking that it could be an impact crater, but it wasn't protected the way Brent was. See, the Brent crater was actually buried in sediment for a very long period of time after the impact, and it was preserved in the mud. And it's about 450 million years old. Craters don't last that long. They only last about 250 million years. But Brent survived because it was covered in that mud in the Sea of Champlain. And the last ice age wiped everything away and washed away and re-exposed it to what we see now. This site here may simply not have been protected the way Brent was. And so any evidence of it being an impact crater are now gone. So this is where we're at. And I can tell you that I was not disappointed at all to not find anything. When we do these explorations, crater or no crater, we had a ball and we were enjoying ourselves. And exploring this kind of thing for me is great. It's something I enjoy doing with Chuck, and that's where we're at with it. Chuck, did you have anything you wanted to add?
The moose was really cute.
You're obviously on expedition way too long.
You sure you didn't come in your tent, Chuck? Okay, so did anyone have any questions?
Just to add something there, that moose did come into our site during the night and bashed down some trees.
Yeah, he knocked the tree down. Yeah, I heard the crack. Yeah. Good thing it didn't fall on your tent there. He was right behind you. It's a mystery site. We've got other sites we plan on going to, but the only thing that would have been disappointing about this trip would have been not going. And I love the new motto at NASA that says, "If you don't go, you'll never know." Thank you. Oh, yeah, you had a question?
Yeah, just wondering, that's a totally remote area. There are no cottages or anything up there, or people who...
No, not the southern boundary of the park is somewhere around here. Okay, so there are cottages further down, and theoretically, from if you were stuck, like if that moose had knocked our canoe over and dragged it into the water and so on, we could have walked back. We would have found the trail. We would have had to find it. It's somewhere in here, and then we would have been able to walk back to the car. But fortunately, that didn't happen.
What does the government say about it? Have they done any research onto that?
No.
Nothing at all?
No, and the only way we knew about it was someone actually emailed Chuck and suggested this site. And we thought, gee, what a great thing to do, to actually explore a place that might be a crater, because all the other places we've been to, we already knew they were craters. And so this was a challenge for us. I also have to say that physically this was the most challenging site we've been to. Right, Chuck? Yeah. But we enjoyed it very much. Yes, sir.
I had a question, but you answered it, I think. The river is flowing south, roughly?
Yes, it goes...
You're not far enough so that they're going toward the Arctic. You're not far enough north.
No. Alciver is, in fact, I think it's south of this latitude. It's it's the southern boundary of the park. So it's actually it's pretty well due west of here. But the river here, we were originally going to start from the north part and make our way down here. And it's a good thing we didn't, because this would have been really tough to do. The trip we did was actually the relatively speaking, the easiest of the access points. We also found out that you can't go from the north because there's no access to cars. Only the people there's actually hydro lines not far from here that the service people go to, and also the natives have access to the park from the north, but we couldn't go from there. Yes, sir.
Any observing at night?
No, it was
Snowed.
pretty well full moon, I think, wasn't it? Or there was a cloud cover. I did take a picture of the moon. It's not in here, and that was it. No, there was no visibility that night, Friday night or Saturday night.
Could you pop up the topographic map that showed that in detail?
Yeah, you can go to the next. Okay.
Yeah, okay, so seeing what you could think of as being a suggestion of a contiguous circular formation, because you can see a little bit of a valley
Yes.
of sorts that completes the circle, okay.
When we flew over it, I because it's a 3D thing, with your eyes, you're seeing it in stereo and with a lot more clarity than any photo can show. I thought I saw an outline, but it was just there, and that's what convinced me. And I kept telling Chuck, driving all the way up, yeah, it's a crater, and Chuck's there, and so we just went and tried to find what we could, and I have to admit, we didn't have as much time as we would like. That always happens. You want to be able to have more time. We spent basically about 6 or 8 hours on the lake exploring, and that's a very short period of time to try to find anything. But we knew what we were looking for, and that outcropping, which is about here, and the island that we were on was here. But the outcropping here, we that's what we looked at mostly, and we didn't like what we saw there. Igneous rock, and I'm not a geologist, but I knew that it didn't look like something that would happen in an impact, and it could still be, but the signs are not there, and so it's not an impact crater.
Yeah, it is igneous rock located at what you would call essentially ground zero of the impact. It should have been well bashed, right?
Yes. Oh, well, what was really cool was some of that rock looked like it had been bent. It's like, like a mattress. It just whoosh, went, some of it was, remember that, Chuck? It had all that weird bending in it, and that's something I hadn't seen before. But I don't know if an impact would have done that, or if it would have been just the sheer weight of the rock coming down on itself. The cracks looked bent, like they had been weighted down. That could be because of the impact. But
if it's a smooth bend, that's the kind of stuff that happens over geologic time, very slow,
yeah,
gradual forces that don't cause the rock to shatter, but to gradually flex like a plastic.
That's right. We saw lots of features in those rocks, Chuck, that you were really fascinated with, and I paid more attention to after I saw that. We learn a lot. I do learn a lot about geology. I just wish I had the training, the formal training in geology. But Chuck's a great instructor in that. He's always pointing out things that I would never see otherwise.
Okay, maybe we can take one more question and then we'll move
I'm
on.
back here.
Yes, Deborah.
Can you send me an article for astronauts?
Sure. Yeah, absolutely. We'll send you a full report. And also, it's on. Chuck is going to be updating. Have you updated your website yet for that?
Thanks for your pictures, sir.
As soon as you get the pictures. Okay. Sorry about that.
One more question here, back here.
Yes.
Just on a slight bit of a tangent here, since the two of you seem to be the RASC's unofficial version of the Crater Busters,
Yeah.
which one of you decided is Jamie?
Oh. Pfft.
Thank you very much.
Thank you.
Wonderful. I always enjoy the trip reports. The moose story reminds me of one experience myself. One caught my guy line from my tent just about neck level, middle of the night one time. Very exciting. Next up, observation reports. We have a number tonight. Paul Commission, Ron St. Martin, and so on and so forth. I think I'll come down for Paul to
That's
speak.
okay, I can yell loud enough.
Not
You
yet.
certainly
No,
can.
no, Bill.
Huh?
We have a strange one first.
Oh, yes, I'd almost forgotten about this. This is Gary had brought this up.
About
Thank you,
3
Gary.
weeks ago, NASA asked if I had anything to do. Hey Chuck, how high do you fly? No, this is a self-portrait taken from Tracy Caldwell Dyson about 3 weeks ago on the ISS, International Space Station. Apparently it took her about 4 days to set up the shot to get the right lighting, the illumination of the Earth. A wonderful self-portrait. Can't you just imagine yourself looking at the Earth for hours at a time? Well, not hours, but to have a porthole like that is truly, truly incredible. All you need is $50 million.
I said I was there. Hands, wait till you get the bill on this one. Okay, folks, just want to share. Thanks.
Beautiful.
Okay, this is NGC 1491, a bright nebula in Perseus. It's just below Camelopardalis, just below the border of the other constellation. This thing is about 21 minutes in size. It's in Perseus. One of the deep sky observers said that this is a very nice object. It shows an odd-shaped glow of about 3 to 4 minutes, and that's what it is. It's I've taken it recently since Glenn has refigured my telescope, so you don't see any donuts this time. Okay, that's fine. Thanks.
Next up, Ron St. Martin.
Here's some more of my fun with film pictures. This was about a 45-minute star trail with the FLO scope in the foreground. It was funny at I was taking pictures with a camera mounted on top of the telescope with a 180 degree fisheye lens, and as I was taking the pictures, in the actual picture, you can actually see my ghost on the ladder because I had to go up there about every 10 minutes and blow dry the lens as it kept fogging up. So you can see my ghost in it. Next one, please. It's another about an hour and a half star trail. Next one, please. This was something with somebody suggested I try with the constellation of Orion. I just had the camera on a tripod. And I did a 90-minute exposure and then covered the lens for 90 minutes, or 90 seconds, I mean, and then exposed again for another 90 seconds to give like a double effect sort of thing. I don't know, looks cool to me.
Really makes the color of the nebula jump out.
Yeah, that was only 90 seconds too, 400 speed film. And this is the comet Hartley 2 over the double cluster. And the next one, please. And this was the result of 2 sleepless nights. I tried to get the pictures of the comet exactly 24 hours apart, so you can see the distance that the comet traveled. And the next one is something cool that Chris did for me. This is really cool. You can see the way it's traveled in 24 hours. Did everybody see that? Do you want to do that again, Chris, please?
Okay. Slide 1.
It cloaked.
Yeah, it's really a Romulan ship, but I just couldn't quite focus on it. I think there was a problem with its cloaking device. And I think that's it.
Ron,
Yes.
on your first picture,
Yes.
you didn't explain why the star trails of Orion and such gradually tapered off and faded out.
Oh, that's because I have a little sock sort of that I put over the lens to keep it from fogging up because I'm letting it sit there for like an hour.
Yeah.
So I have a little, like a hood, and sometimes, in the dark I can't really see if it's round or not, so it blocks off a little bit of the image because that was with a 24 millimeter or a 28 millimeter lens.
Well, I'm looking at all the stars, and they all pretty similarly fade away. I was thinking that actually your lens was fogging up and
Oh, it might have been.
attenuating the light.
Hey, I don't know. It's 3 o'clock in the morning, man. I was like half asleep. See, all you can see is my ghost.
Not even half there.
No, half cut. No. Anybody else? Great. Thank you.
Very artistic. Thank you. Next up, Richard McDonald.
Just this one image. This is a quick image that I did this summer. I was doing some public outreach at a provincial park. You set up a telescope while camping and you're doing outreach immediately. And it's not a very good solar image. What amazes me is that it worked at all, because this was an Altaz mount, not motorized, and the camera was my cell phone. I just kind of held it up to the eyepiece and went click, and I got that. So I was actually quite surprised that it worked out that well, considering that it really had no right to. So it was so I was pretty pleased. So.
Very, very impressive.
So is that a hydrogen alpha filter on your cell phone?
Yeah, the iPhones come with hydrogen alpha.
Next up, Wayne Ross. Wayne, welcome.
Right, did you know that the laser was there?
It's there.
Should be right there.
Center button.
Kick
Yeah,
the
big button in the
answer
middle.
machine. This thing, the big button in the middle?
Yep.
Just two images that I took with my ED80. Both we had those nice days in October, and then this one here I think was on just the evening of Remembrance Day. And after I take the pictures, I usually go online and I try to look up more information about the different objects in there and the history. And what was interesting was I found a bunch of amateur websites and really some good work that said that the Flame Nebula here, which is NGC 2024, is illuminated by Zeta Orionis up here. And started reading that some of the distances, when we consider that this nebula here and IC 434 are about, and also 2023, are about 1,500 light years, give or take, because once you get past 1,000 light years, parallax begins to become a little bit difficult for measuring distances. This star, according to the Hipparchus survey, is about 815, 820 light years away. So it's unlikely that it was actually illuminating this nebula. So it got me looking. So I work for a scientific organization for the government, so I can read some of these journal articles at work, and people don't really pay attention. So I pulled up some journal articles from 2007 and 2003 in astronomy and astrophysics, and using Spitzer and Chandra infrared and using some Arecibo or radar stuff. Right in here is a star cluster that's forming, and inside that is an OB supermassive star. It's IRS 2b, and it's believed to be, it's hypothesized to be the illuminating source. There's still a couple of academic papers that say that it might not be. And what's really cool about this is there are five, in the 2003 research that was done, there are 5 brown dwarfs right down in here that have disk envelopes. And they believe that this is some of the first evidence of, or when the paper was done, some of the first evidence that brown dwarfs can form planets. And they haven't imaged any planets or anything like this, but this is one of the hypotheses that are coming out here. Fascinating thing. The only other thing that I learned that I thought was really cool, and this might be an astronaut's thing, we have the Horsehead B-33. There's Wilhelmina Fleming, way back, a long time ago, worked for Pickering at Harvard. And he was all upset one day, I guess, with his male assistants and the like, and he said, my maid could do a better job. So he hired her, and Wilhelmina Fleming was his maid. And I believe it was her who first identified this on a photographic plate from Harvard. There was Barnard and others who had later looked at it. So that was just a little thing on that. So next one, sorry, there should be one more, I think. Is that it? So, my wife is really nice to me sometimes, and she says, get out. So when she does that, I usually have the car packed from the day before, and I had 3 days where I was really lucky, and I have a 1-year-old and a 3-year-old, so once I get them to bed at 7 o'clock, I book right out of the house. Just 3 hours worth of exposure. I took 29 images of 5 minutes and 10 minutes, and I can't remember the exact divination on the matter. But a really cool thing, when I'm reading through the pictures, I'm cleaning up the hot and cold pixels, and I'm zoomed way in. And if anybody can tell me what this is, I'd be just a happy little camper. Tim Cole and I were talking about this earlier. Up here, and it's too faint to see, is a galaxy. And I have no idea what it is. Look in the PGC catalog, and I can't find it. So if anyone knows what it is, I'd love to find out. It's just up in that area there.
Do you have an idea about what its magnitude would be based on your own images and the depth that they
Faint.
go to?
Actually, the seeing is really good, and when I checked the individual frames, because it could have been, bug could have landed on it, it's not so much in the 5-minute ones, but when I'm in the 10-minute frames, it's there, so 17 maybe, 16, if I'm lucky.
I think it would appear in the PGC catalog.
Oh, it's probably there. I just probably not entering the numbers properly, trying to find out what it is. But it was just very faint, and it's an edge-on galaxy. And I couldn't find any others anywhere else in the frame, but I didn't know there was a galaxy here. And if no one else has found it, I got a cool name for it. Yes, please.
A comment there regarding that business with Zeta Orionis and
Yes.
the Flame Nebula. There is another famous object where in the past there was thought that another bright nearby star might be illuminating a nebula. That's the case between Deneb and the North America.
Really?
Yes, up until the 70s, you'd seen lots of books for amateurs where it was proposed that maybe Deneb is lighting up the nebula, up until about the 70s. And then it was realized, no, it can't be the case because Deneb is not hot enough to produce enough ultraviolet.
Right.
And then it was later identified that, the star lighting it up is actually obscured deep behind the dark nebulosity separating the North America from the Pelican. So here we have the same kind of a case where it's, it's not the obvious thing, it's something that's hidden behind the murk.
It's usually bring this up because I'll get going since it's getting late, but when I was looking at Zeta Orionis and looking at some of the data, I have a wide field image of Orion that I took with a diffusion filter. I separated all the stars and I put them on a graph. And I was looking at the luminosity, and when you look at Zeta Orionis, it's about 100,000 times our sun in UV. So that's one of the things that may have also contributed to people thinking this case. I mean, it would just cook you if you were even 8 times out further than Pluto is from us. That's cool. Thank you very much. Sorry,
Can
yes.
we go back to that photo?
Yeah, please. I don't know how to make it do it, but
Yeah.
Cool.
Sigma Orionis, that's the cluster up to the right. Glenn, do you remember, is the illumination from that affecting the Horsehead at all?
yeah.
Well, yes, that's what's lighting up IC 434, and the radiation pressure is sculpting the molecular cloud material. The Horsehead is just a bit of a denser thumb that's kind of sticking up and is being gradually eroded by the stellar winds and radiation pressure that's eating into the molecular cloud, which is taking up the entire lower left part of the view and then some. The molecular cloud is all the dark, dusty gas that the stars are being born within.
And apparently, if I can just add that, 2023 is apparently one of the brightest fluorescent hydrogen sources around. The one other thing, just on this, is the 3 stars. This is obviously the leftmost star in the belt of Orion, and up here we've got, and I can never pronounce it properly, but the middle star in the belt, which is not Mintaka, is actually closer to this entire complex. It's about similar distance, yet no one seems to attribute it to any contribution to this issue.
Well, just be careful with the Hipparcos data because at that distance the error bar is pretty
Well,
low.
exactly, and that's the other thing I learned, which was really kind of cool, was the parallax after 1,000 light years becomes very problematic.
Almost meaningless.
Absolutely, and here we're dealing with 1,300, 1,500, ranges, and so we really don't know once we get out there. And when you try to, figure these things out, we get very interesting stories, I think, that come up, and some good science that's starting to be done there.
Just doing a search over here on cloudy night telescope reviews.
Yeah,
Under galaxy, that could be PGC 13696.
13696.
Just throwing it out there.
Cool, thank you. I appreciate that. Thank you very much.
Wayne, what's the camera?
Oh, sorry. I'm new to this. I actually been doing this a little over a year or so. I did. Pardon me. I actually did photo editing at a major newspaper way back in the day. I'm using an ED80 apochromatic or a Skywatcher on an HQ5, but I'm using an unmodified Canon Rebel XS, and I just generally take care when I'm doing the processing. And I treat this more of an artistic exercise as opposed to a scientific exercise. Eventually I'll get to, I want to do narrowband eventually, but my wife won't let me pour the pure in the backyard yet.
Thank you.
Pretty decent shots for an unmodified DSLR. Next up, our Observer of the Year, Sanjeev.
That was last year. What have you done for us lately?
Okay. Well, thanks for the award, Bill, and Deborah. Yeah, so November was actually a really good month. I think many of you probably got a chance to get out. We had several clear nights, and of course the nights are very long in November. And it was 1 year ago in November that I think I showed you a picture of M31 with my DSLR. And that was a year ago. I think in the astronomical night was 11 hours long, and that night I had 3 images with my DSLR. Now, in this November, I actually had a bad cough and a cold, so I didn't do any sort of 11-hour marathons, but I did several marathons, so a bit shorter. And all of them were at FLO, but I only brought 3 pictures to show you today because I thought there was too many pictures to show, so I picked 3 of them. Now, this is M31, and I did this at FLO on November 1st, and it's about 4 hours of exposures. And it was with my Teleview 85 refractor. So the scope is 3.5 inches. And the thing about the picture is the camera. The camera is my CCD camera. It's a QSI 583. And it has really small pixels. And it's the same camera I've been using for the other photos I've shown you guys before. And I guess people used to think that these cameras with small pixels, would have a lot of noise or would not have much sensitivity. And this particular chip, the KF8300 chip, a lot of manufacturers are not using it in the CCD cameras, and it's turning out to actually be a bit of a wonder chip because it is 8 megapixels, and the pixels are small, but you can still get pretty good signal and not much noise, and the whole chip is only about 18 millimeters wide by 13.5 millimeters on the side, so the diagonal of the chip is only 21 millimeters or 22 millimeters, so basically it's small enough that your optics don't have to produce a huge, well-corrected field. So on the Teleview 85, which has, it is designed, it can illuminate a DSLR chip fairly well, not a full-frame one, but it's basically the amount of, you're not going to get any aberrations on the edges. That's my point, is that you can get an 8 megapixel image with most optics that will fully illuminate the field. So in this case, what I did was I did something slightly a bit more labor intensive than most attempts at M31, which is I shot separate exposures. So I have 4 filters, right? Luminance, red, green, and blue. I actually shot 12 sets of exposures because I shot 3 exposures through each, three sets of exposures. So that's to keep the core from being blown out, because the dynamic range here, the core is very, very bright compared to the arms, and when you're processing it, you can stretch it so that you're not going to blow this out. But even then, there's only so much you can do to avoid having the core fill out this whole area here. So I did a series of 1-minute exposures and a series of 3-minute exposures, along with 10-minute exposures in my luminance. So to make a long story short, this image is a composite of several sets of exposures, with the core being from the shorter ones. Yeah, and then there's M110 and M32 and M110. See, this whole area here is the halo around M31, and actually the distance here is only about 2.5 degrees. So I actually don't have enough field to cover the full extent of the galaxy with this particular telescope and camera combination. It's at 480 millimeters. So if I had about a 400 millimeter telescope, I would probably have gotten the full field. Okay, next image, please. Okay, so I'm going to show you 2 more pictures, and these next 2 I'm showing you are with my bigger refractor, which is a 5.5-inch refractor. It's the Tech 140, and I'm shooting at about 1,000 millimeters of focal length with the same camera. And this is M78. So Wayne was showing you earlier the Horsehead area. This area is believed to be, it's just slightly close to where the belt of Orion is, and this is M78 right here. And this area here is, they're both reflection nebulae. This one is NGC 2071. If you look in the scope, you basically see this, it looks like 2 little eyes poking out of a dark space in the eyepiece of a telescope. This is believed to be part of the same sort of molecular gas complex as the Orion Nebula and the Horsehead. This area here is about 1,600 light years away. And the other thing to note about this image is that it actually, compared to how we normally see the sky, this image is upside down, because normally the belt would be up here, the belt of Orion. So this is actually upside down. The reason I put it that way is because my wife liked it better that way. She said it has to be a cup. Right. And actually, I liked it better that way too. Okay, that's my last shot that I'm going to show you tonight. So this is M42. It's with the same telescope, my 5.5-inch refractor, and we're looking at 3 hours, 15 minutes of exposures. Now, this is a target that I've shot many times. In fact, when I first started imaging from my backyard 2 years ago with my DSLR, I repeatedly went after the M42 because it's really a challenge object, because there's a lot of, for imaging, because there's a lot of brightness here. And so normally you would blow this whole area out, it would just be all white, the pixel would be saturated. So to get the outer nebulosity and this, you have to do a composite. So this is same idea as with the M31. What I did here was I shot 5-second exposures, 30-second exposures, and then 6-minute exposures. So again, I had 12 sets of, because I had 4 filters, right? So I had 12 altogether, 12 stacks of exposures to process. And then in Photoshop, you can use this thing called layer masks, which allows you to combine all of them. And when I was processing this, I was getting a little bit worried because I thought, I had to kind of take a rough guess of, should it be 5-second, 30-second, or should it be 1 minute, 2 minute? Basically, you can blow this out very, very quickly because it's so bright. So I went to, the lower end, so I went to 5-second, 30-second. And as I was processing it, I realized, because in the 6-minute exposures, this whole area here, it just looks white, right? So I thought, why am I getting this very sharp difference between this sort of a pinkish area here and this kind of a whitish area here? Like, it's such a stark line on this side. And I thought that was part of what had gotten blown out, like saturated. And I tried to look, I went online, I looked at a whole bunch of images that had, other people had taken, and I couldn't really tell. And then I went and looked at the Hubble image. If you look at, there's a picture by Hubble, there's a recent picture of M42, and you look at that Hubble image, you'll see that there is in fact a very strong straight line there.
Or you could have asked a visual observer, we see it all the time.
That's true, actually, and actually I did remember that too. But when you look at it visually, it can be misleading, because when you look at an object visually, and I've observed this very times visually as well, is that it actually looks very blown up. When you're shooting prime focus with a telescope, you're not going to really get the same level of magnification that you see visually, because visually it's true. What you see visually is it looks like a bit of a fish, right? You see this round part here, and you see something coming out this way and this way. And if you're at a dark side, you'll see this sort of a wispiness, this arc. But from the city, you tend to just see this part here, right? And you see these 3 stars and the trapezium. So you're right. Visually, you would see that, but I didn't make that connection right away. Anyway, so that's it.
Sanjeev?
Yeah.
I have to say that I don't think I've seen a picture before that quite differentiated as strongly as we see here the gas emission and the dust. The blue dust stuff really is standing out so well. And for those that might not be aware, all that blue wispy stuff, that's just interstellar dust grains that are just scattering the light from the bright stars in that trapezium cluster. But these dust grains are about the size of cigarette smoke particles, which is why you get that bluish color. Just like cigarette smoke in a shaft of sunlight in a room gives a kind of a blue cast to it. It's a very similar effect.
That's right.
Hey, well, thanks. The other thing about this is, if out of the exposures, 80 exposures went into this picture. So it's a labor intensive, even though it's only 3 hours, 15 minutes of exposure time.
Sanjeev, it's one of the best M42s I've seen too.
Thank you.
Bravo.
Yeah.
Thanks.
And last up tonight is Rolf Meyer with some beautiful photographs of Jupiter.
So here's Jupiter in October. 3 pictures. And what I noticed when I took these and stared at them for a while was I realized that they're actually about 120 degrees apart each. And since they were just taken a few days apart, basically it covers the entire disk of Jupiter in fairly uniformly. So the next slide, so I made a map which is on the bottom, and that shows basically the entire disk of Jupiter as it's been derived from those 3 images. And then if you could click on that, that is a rotating globe made from that image. So that's 3 images put together. What?
Put your finger under it and do it.
I just can't resist.
Okay, well, all right. Okay, so might have been a little bit better if I had been able to get them closer together in time, and maybe if I'd had more than 3, but anyway, there it is. 3 will cover the entire planet, not too badly.
Nice.
So I believe there's one more. So this is November 11th, and just want to point out this is just with a 6-inch telescope. So you can get images like this with just a 6-inch telescope, and that's it.
Well, thank you, Rolf. A very impressive set of images tonight, I'd say. So just finishing up, a few loose ends. First of all, as we've started doing over the last little while, each month Estelle will choose one of the books out of the Center Library to bring to the fore. Basically, what we're trying to do here is just promote awareness of the content of the library. I think a lot of people kind of overlook what is a pretty impressive collection. So at least this way, you do get exposed to what's there, and something might just twig your interest. Head over after the meeting, and you can draw out that book, or there's a whole lot of other ones that we haven't talked about yet. So this time, the meteorites of Alberta. Don't have much of a description. Is Estelle here?
Yeah, I'm here.
Yep.
The book will be in the library.
Excellent. Okay. Next up. Is the library going to be open tonight?
Oh, yeah.
Good, great. Next, as Gary mentioned a little early, I think it was Gary. Yeah, Paul, sorry. Paul mentioned the center now has a Facebook page set up. We welcome you to go take a look, see what's going on, contribute to the discussions that are going on there. This is the wall page for it, and
I just moved.
oh, okay.
If you don't have any photos, if you want to contribute photos, please do.
Yep.
It's a great way of public coverage too.
Yep, you're right. So sort of an open center for discussion. Oh gosh, 6 attending, and there's me at the top. You'll notice that's not a telescope I'm holding. Anyway, fair enough. Everybody knows what I do. Onward and upward. Public observing. So first of all, the total lunar eclipse. Did Mike want to talk about this, or I just go through it? Mike? Mike's not here. Okay, I'll talk about it. There's 2 back-to-back observing sessions, basically, both of them, weather permitting, but the total lunar eclipse, which is the morning of December 21st, as we mentioned, night of the 20th, morning of the 21st, from 1 a.m. to 4 a.m., give or take. Gary had the accurate figures, outside HSH Observatory. So if you are up and about at that hour in the morning, my God, who would be? But, if you are, you may find like people, with similar problems there. You can discuss that. Next, please. Winter solstice is the next one. That will be the evening. So December 21st, of course, being the winter solstice. I think there will be druidic dancing. Brian will probably be attending and such. But anyway, there's looking forward to the longer days and shorter nights and harvests and all that sort of thing. So anyway, also in the same place. This one at a more decent hour of 7:30 to 9:30. So see you there. Next up. After the meeting, the book library is open, as Estelle stated. The equipment library, I didn't see Al tonight.
Al's not here tonight.
Okay, no Al tonight, so probably no equipment. Loan library, coffee and conversation as usual. Art and Ann Fraser outside in the lobby. Membership info, Art, basically the info's all online anyway, but if you need to ask questions or such like. Membership cards, which of course are no longer in the Astronauts because the Astronauts is online. It's hard to put them into the online. But anyway, you can see Art about that. Sky and Tel and Astronomy renewals. For those who don't know, there's a discounted sort of a deal on subscriptions. See Stephen McIntyre about that. Reminder, the rest of the museum is closed, so please don't wander into the rest of the museum. I think there's a bunch of children. You'd probably frighten them tonight going over there. But stick to the lobby and things should be fine. And the usual reservation has been made at Kelsey's. Head on over. I guess it's in the name of RASC, that sort of thing. Snacks, drinks, dinner, that sort of thing, and conversation. Tonight's attendance, 114. As I said, you had about a 10% chance of winning the answering machine. It's still there. Many thanks to the organizers and speakers, that guy, whatever his name is, Chris, Paul, Eric, Paul Commission, Ron St. Martin, Richard McDonald, Wayne Ross, Sanjeev. See, Sanjeev, we did remember you. And Rolf Meyer. I'm only saying that because we forgot him once before and he thought we had it in for him, but not really. Thanks to our host, the Canadian Science and Technology Museum. They provide us with this wonderful space and stuff. Complaints and such, to me, the email address has changed for those who didn't catch it the last meeting or so. I'm weaning myself off of Rogers, so I'm now bill.meeting.chair@gmail.com. Shouldn't be too hard to remember, right? Next meeting, 8 o'clock, Friday, January 7th. Be there or be square. At least it's not, right after the holiday, so you get a bit of a break. And it'll be here. Thank you all. Have a safe drive home.